Hello, welcome to the third lecture on simple machines. So today we'll be focusing on one of the type of simple machine, which is a lever. Our objective of this lesson today is that at the end of this lesson, students should be able to explain what a lever is, state the classes of levers and examples of each, and calculate mechanical advantage and the velocity ratio of levers. So watch this video so you will learn more about levers.
The lever. When we want to raise a huge rock, we could use all our strength to move it. On the other hand, you could move the rock with a rod by applying less force. The energy you spent would be much less. Here, the rod is called a lever. The rock is the weight or load L. A small stone kept near the rock under the rod acts as a support for the rod. The point where the rod touches the small stone is the fulcrum F. The force applied to push the rod down is the effort E. Levers are classified into three types. 1. First class lever. 2. Second class lever. And 3. Third class lever. First class lever. When the fulcrum F is in between the load L and the effort E, it is a first class lever. Examples of first class levers are scissors, claw hammers, seesaw, crowbar, pliers, etc. Second class lever. When the load L is in between the fulcrum F and the effort E, it is a second class lever. Examples of second class levers are bottle opener, can openers, wheelbarrows and nut crackers. Third class lever. When the effort E is in between the fulcrum F and load L, it is a third class lever. Examples of third class levers are ice tongs, spades, fishing ropes, forceps, etc.
Okay, how do we now calculate the mechanical advantage and the velocity ratio of levers? Now we said we have three types of levers. We have first class levers, second class levers, and third class levers. So there has a formula. So mechanical advantage from the previous lecture, we said mechanical advantage is equal to the load divided by the effort. So if you know the load here, we know the load, which is 100 newtons, and the effort is 200 newtons. So now from there you can able to calculate now the mechanical advantage. That's the formula for each of these levers. So the formula for second class lever will also be the same. If you write like this. So you have mechanical advantage will be equals to load divided by effort. That for the third class lever, but also you have mechanical advantage over load divided by effort. Like in the first case, you see that they have given us some values there. So we equal to, if you want to use those values, it will be 100 newtons, 100 newtons divided by 200 newtons. So you see your answer, they're giving you 0.5. 0.5, so it has no unit, so I like that. Now, so what's the velocity ratio? So the velocity ratio formula would differ a bit by the manipulations. For example, now first class lever. So what's the velocity ratio? The velocity ratio is equal to the distance moved by the effort divided by distance moved by the load. Now, what's the distance moved by the effort there? So this is my effort at point A. So this is a distance move. So you move from point A to point B. So this fulcrum. This is a fulcrum, this is a pivot. So from point A to B, so it'll be AB the distance AB divided by the distance moved by the load, which is from B to C, should be divided by BC. So in using that values there, you will see that we will have 2 meters divided by 2 meters divided by 4 meters. So now you'll be giving your answers to the same 0.5. So there's no unit because velocity has no unit. So in this other case, case 2, for lever, second class lever, velocity ratio will be equal to distance moved by effort divided by distance moved by load, which should be equal to, now, what's a load? This is my load now, and this is my effort. So it has changed. Now distance moved by load now be effort now be from A to what? To C. So you have seen it has changed. A to C. So you are taking that our focal point, our reference point should be at the pivot. So wherever the pivot is, that's where we take our reference point. So our reference point is now is at A, which is a pivot. So it will be AC divided by the point from the pivot, the reference point to the load, which is what B now. So you see a bit it has changed from like the value above. So if we're using the same values above, you see that distance moved by the load we cannot use because it is there are different distances, so it has changed. Now if you look now, next one, velocity ratio for third class level now will be now velocity is distance moved by the effort divided by distance moved by load. So what is effort? This is my effort now. So distance moved by effort now be from the pivot now to point B, which now where the effort is. So we equal to AB divided by the distance moved by the load now is from A now to C. So you have seen that it has changed. So for the velocity ratio, where the calculation, the distance that you take varies depending on where the load is or the effort is. So the formula for first class level cannot be used. The same principle can be used to calculate it, but the same formula cannot be used for first class level and for second class level because where the load and the efforts are different. So take note of that.